show you some questions that are allocated for week 2. Now, in an earlier tutorial, I already solved a few questions involving lines and vectors. So today I thought we could start by doing planes and vectors. Now, it's not the plane that you fly in, of course, it's the geometric plane. So let me show you a couple of questions and we can discuss them. All right, so if you've got questions, etc., feel free to pipe up in the chat, okay? All right, so this is one of the questions from today's tutorial, part B. The list of questions are in Moodle, and I thought we could discuss these, and then if we have more time, then of course we can discuss lots of different things. Okay, so one of the suggested questions is 39 part B. So basically you've got 3 points and you're asked to determine the parametric vector form of a plane that passes through these points. So I'll do this a couple of ways. First, I'll draw a picture, and then I'll do it by hand, okay? Some of you already know that I really like using GeoGebra and other basic programs to help with the visualization. So let me bring that up, and I can just share it with you, and you can see what you think. So let me share that with you, okay? So hopefully you should be able to see this now. So this is GeoGebra. I'll put it in the chat. Some of you, I know there's a big Desmo crew, and there are many other ways to visualize, mathematics and whatnot, and geometry and sets. But this is a nice one. It's just a really simple thing. So what I've done is I have put in. So Vicky, they are. Yeah, thank you, Evan. They're in Moodle. You can find these questions in Moodle in the course pack. Okay. So you can see 3 points sitting in 3-dimensional space. That's all we need for the equation of a plane. So if I go plane A, B, C, it is. Oh my goodness, that was easy, wasn't it? So at once, we've got a plane going through these 3 points, okay? So you can even see that in the GeoGebra gives you an equation for the plane, okay? And this is known as the Cartesian equation or something like that. Okay, so that's kind of what it looks like. What are some other ways of getting the equation of a plane? Well, you can compute the vectors, 2 vectors and a point on the plane, or you can get a point on the plane and a normal vector. So these are all different ways of doing it, okay? So let's have a look at how we might solve this just by hand. So I'll just share my, my screen with you. Let's see if I can share this Chrome tab. Okay, yep, give that the big thumbs up. So 39B. All right, so let A have this position, B have this position, this point, the coordinates, and C is here. So what is the equation of the plane connecting these 3 points, if you like? So the plane P through A, B, and C, what is it? What is the equation of the plane? Okay, So can you guys see my screen or not? Okay, great, fabulous. Sorry, just I get a little bit concerned when somebody says in the chat, "Oh, I can't see something." All right, thank you guys. All right, so can anyone suggest how we might do this question? What might we want to do with, we've got 3 points, how might we want to get the, let's say the parametric vector form, right? So we want the PVF, parametric vector form of the plane. Any ideas? All right. Hussein, I don't know where Dr. Law is. Sorry. Yeah, Florence is on the right track. ZG2, yes, find the 2 vectors between the 3 points, and we can maybe make one of these points the extra bit, right? So let's try that. So we have, I don't know, let's find that vectors AB and AC, Nicholas, that sounds good. So the vector from A to B is the position vector of B minus the position vector of A. And so how do you do it? You just work component-wise. Okay, and let's do, I think I'll do AC. Okay, so that will be vector C, position vector of C minus the position vector of A. Okay, so work on that again. 1 minus 1, 0, negative 14, and 3 minus negative 2, that'll give you positive 5. Okay, so this can be like a vector that's parallel to the plane, and this can be a second vector that's parallel to the plane. Now, we need to be a bit careful here. Are these 2 vectors parallel? Yes or no? Who can tell me in the chat? That's right. And a quick, you're absolutely right, everyone. Well done. A quick check is you've got a 0 here and something that's non-zero there. So obviously they can't be a multiple of each other. All right. So let's make this parametric vector form. So PVF means parametric vector form. All right, so it's going to be something like this. So let's do lambda 1 V1 plus lambda 2 V2. Okay, the OA is just the position vector of a point on the plane. V1 is either of these vectors, V2 is the other one. Lambda 1 and lambda 2 are your parameters. Okay, they're kind of like the variables. Okay, so if we put that in, we'll get something like this. 1, 4, negative 2 plus lambda 1. Okay, so we can choose this one to be V1 and this one to be V2. Okay. All right. So Juncheng, the questions are in the course pack, the Moodle course pack, the course pack on Moodle, the algebra PDF. Okay. So all you've got to do is go to Moodle. It's the first thing you see when you log in. Fantastic. Excellent. Okay. So a couple of questions, everyone. Does it matter if I have the vector AB and AC, or could I choose some other vectors? Like, could I choose AB and BC down here? Would that work? I'm a little confused. It's late in the afternoon. I'm still a little bit confused. Yeah. So some people are saying also, if I get this right from the chat, could choose, say, A, B, and BC. Right? Yep. Good job, Florence. Vectors, as long as they're not parallel, these are fine. And what about, I used the point A up here. Could I choose the point B and the point C? Would they also work in here? Yes, they would. Okay. So this is more of a secondary thing. What some people get a bit concerned about, right? I'll come back to this in a minute. Some students, they ask a lot of questions saying, oh, I solved this plane problem, and my answer isn't the same as the answer in the back of the book, and then they get really worried. The point is there's many ways of expressing the equation of a plane or the equation of a line, parametric vector forms, okay? So if your answer is different to your friends or what's in the back of the book, it doesn't necessarily mean that you're wrong, okay? So let me go back and I'll put that back up, okay? Now another option, the direction of these vectors don't matter, right? So I could have actually computed VA and CA or CB. The direction actually, like, all you're really worried about is that these two things are parallel to the plane. It doesn't matter if they're pointing in that direction and then or that direction, as long as they're parallel to the plane, okay, and not parallel to each other, okay? So if I go back to my little GeoGebra picture, let me see what I can do there. Here we go. All right, so you should be able to see that now, okay? So if I compute, let's say I let U be the vector from A to B, right? So you can see there I've got the vector joining that point. That vector is also parallel to the plane. Can you see that? I don't want to make you dizzy, right? And if I make V be the vector, I don't know, let's say from A to C, okay, there that is. And can you see how they're both parallel to that plane? Oh my goodness, how good is that? Okay. And then one other thing, I'm not sure if you've seen this in lectures, but if I do the cross product of U and V, a normal vector. Oh my goodness. Okay. And it's sort of sticking out a long way here, right? That's it. That's sticking out a long way, but it's normal to the plane. Okay, so a couple of important things there. GeoGebra is very helpful, and I see Zheng Yu. How about direction? They might be opposite. It doesn't matter, right? Like as long as they're not parallel, the vectors, not parallel to each other, but parallel to the plane, then that's okay. Okay. So can a final answer be of any length along that plane? What do you mean, Zach? What do you mean final answer? Yep, we have the equation made. Do you want to type the equation into the chat? If you can. Oh, okay. Well, Zach, have a think about it and see if you can come up with something, because then it'll help me understand. Or you can just turn your microphone on a bit later. Let me know if you want to speak, okay? Because sometimes that's super helpful. All right, Shujun, why does the plane equation come out by adding the direction of AB and the direction of AC? I think it's a great question. Let me go back to the picture. So let me just go back to this. Okay, so I can get rid of that. Okay, so I get rid of that. Okay, so sorry. Okay. So Shujun, it's a good question. Why does the plane equation come out by adding the direction of AB in the direction AC? Well, the basic thing with planes is you need 3 points to uniquely describe a plane, okay? And see the A point down there? If you go from the origin to the A point, that gets you onto the plane. And then the vector AB and AC move you around the plane, okay? So let me actually write this down, because it's a good question. Okay, so let me actually write this down. So I'll just go back to my document camera. So I'm just going to share my document camera. All right. So I can see it's coming up in the chat, right? So questions? Do you have questions? All right, so here's the origin. All right, now I want to get from the origin to any point on that plane. Okay, so if I know a point on that plane A, then the vector OA gets me onto the plane, right? It's a two-dimensional thing. So if I know another 2 points, let's say B and C, let's say this is vector V1 and V2. These two vectors enable me to move around the plane, okay? If you want to move around a two-dimensional object, you need two vectors, right? So let's say I wanted to get here from the origin. Let me do that a bit better. Okay, I wanted to get to that point. What I would do is I would go that plus that and that. So you get in there. Oh my goodness. Okay. So Shujun, is that making sense? The two vectors here that are parallel to the plane, they allow you to move around the plane. Okay? Yeah, like a linear combination. Okay? So that's what's going on here. But essentially all you need is 3 points to describe a plane. Okay? All right. Zach, do you just want to talk? Zach, just fire up your microphone and talk, man, because I think now's as good a time as any to talk.
No, yeah, sure. So with, say, that diagram you have right there, if, say, could it be on any point along that plane, or is it fixed in a certain area that we could have that point where the green point there, can it only be in a certain area, or can it be anywhere along that plane? That's what I mean. It's kind of hard to say. Yeah.
Yeah. So the green. So you want to basically get to every point on the plane, right? And
Yeah.
none of these are unique. You just need to know 3 of them, okay? Or this vector, and one more point. That's all it is. And I think you're right about the lengths. The lengths don't matter, especially for these vectors. They do not matter. It doesn't matter if you have a long one or a short one. It doesn't matter, because you can always scale it to get wherever you want to go. Does that make sense?
Okay. Yeah. Yeah, that's what I was looking for. And as well, AB and AC, do they have to be perpendicular to each other, or do they have a certain relationship? No. Okay.
No. As long as they're not parallel, then, because if these two things were parallel, you could only move in along a one-dimensional line. So here, because you've got a 2-dimensional object, you want to be able to move along a 2-dimensional path, or a 2-dimensional sort of directions, if you like.
Yeah, thanks.
Yeah, Shujun, that's a good question. What about the other direction? So that's fine, because you're just scaling this vector, or stretching, or flipping, or whatever. So if you want to get to a point over here, you would get to A and then flip these around. So let's say you wanted to get here, you would get there and then negative something times V2, and then minus a plus a little bit of V1. Okay, so that's why it has this kind of format, right? So you have OA plus, I'll say, lambda 1 V1 plus lambda 2 V2. These lambda 1s and lambda 2s can be positive or negative, right? So if you want to get over here, you can flip them around. The direction here doesn't matter. You can go AB, BA, AC, CA. It doesn't matter. Correct, Sichuan. Lambda can be any number, right? Lambda 1 and lambda 2 are just real numbers. Oh, Jessica, great question. X, in the simplest case, is just, that's your X here, and it's just the position vector of every point on the plane. Okay, that's a great question. I remember when I was a student, I had no idea what this meant. It's just a vector, position vector, from the origin to any arbitrary point on the plane. Lucas, yes, you can. Yep, that's exactly what we've been doing. Yes, Stephen, lambda can be irrational. Yep. Have you been talking with Norman Wildberger? It can be irrational. Yep. All right, Shujun. So we can come out with direction OA plus lambda direction. Yeah. Yep, that's right. That looks right to me. I'm loving the chat. I am loving the questions. Okay. So let me, and I love that recorded message before that somebody put on their mic. I love that too. All right. So let me move on a little bit to the next question. So let me just share another poll with you. So just hang on a second, everyone. Here we go. All right, so I've showed you GeoGebra before. Is it helpful? Is it not? Do you care? If you don't care, that's fine. I just want to see what you think. All right, so let me go back to the next question here. So the next question is 41. So I'll just share the screen again, and you should be able to do that. So 41F. So here we are asked to find the PVF, parametric vector forms, for the following planes, okay? So this is the one. This is the one. Okay? Okay. So through the point 1, 2, 3, 4, parallel to the lines here and here. Okay? All right. Okay. So Shujun, you just look, there's a link in the chat. Just have a look. Someone put it before. Okay, it's on Maple. Yeah, thank you, Nicholas. Okay, so how might we do this question? I'm a little confused. We're in sort of four-dimensional space now. What do we need? What do we need? Well, can anybody suggest how we might do part F to get a parametric vector form of a plane? I'm a little confused. We've got lines here. All we're told is it's parallel to the lines. All right, ZG has a suggestion. Transform the last part into vectors. Then we have two directions. Okay, well, let's work with that. I think this is a vector that's parallel to the line. And down here, down the bottom, that's also a vector that's parallel to the line. So maybe we can use that to work out our equation of the plane. So let me write this down, and I can share my screen again with you. Okay. All right. So this is 41F. Okay. So we've got a point which is 1, 2, 3, 4. And we've got two lines. Now, if we can work out the vectors that are parallel lines, the vectors that are parallel to those lines, then we can work out our plane equation. So here, from the first line, we're going to take 4, 0, -4, and 5. And from the second plane, we're going to take 7, 2, -3, and -5. Okay? So actually we've got all the bits for our plane right here. So this was actually the parametric vector form of our plane is, well, we know the general form. Now, I didn't check to see if these were parallel or not, but they're obviously not, because there's a 0 here and a non-zero number there. Okay, so let's just write it out. Okay, and we want to specify that these parameters are they come from the whole real line. PVF, parametric vector form. Parametric vector form. Okay. Yeah. A good question, Zhengyu. Okay. So yeah, that's the question for 41F. It was a pretty easy question. So we just leave it like this, and that's all we need. Here, the X is, we're in 4-dimensional space, right? So if I wanted to sort of, if you're saying, well, what's X here? It might be like, you know, X1, X2, X3, X4. We sort of need to add another one. Okay, we need to add another one. Oh yeah, Cartesian form. So that's a great question, Tash. One of the things you can do when you have a PVF is to do the cross product of the two vectors, and that gives you the normal vector. And then you can write it as the parametric normal form, PNF. And from that, you get the Cartesian. Okay, it's pretty easy. I might be able to show you an example of that in a minute. So it's a good question. Okay. Yeah. Yeah. Why? Because there's two. That's a good question, Rex. Is it still called a plane? Yeah, because it's still two-dimensional. There's two parameters, right? So a line. Let's say that's your line. It's one-dimensional, right? So you only need one parameter to move around. If you have a plane is two-dimensional. So you need two parameters, okay? One parameter. You need two parameters to move around, okay? All right. Evan, where are you? Where's your question, Evan? Can you, okay, can you explain the 7, 2, -3? Okay, yep. So let me go back. All right, if I missed your question, just remind me, Amelia, thank you. So let me go back and share the PDF. All right. So you should be able to see that. So you can see here, this form here is the Cartesian form of the equation of a line, okay? So the 7, 2, -3, -5 are the coordinates of the vector that is parallel to this line, okay? And 5, -6, +2, -1 is a point that lies on the line, okay? So I'm just looking at these things and go, oh, right, well, I know the bits in the denominators are just the bits for the vector that's parallel. So that's where I'm taking it from, okay, just by definition. Evan, does that make sense? Okay, cool. So what in that question, we're looking basically for two vectors, that one, this one, and the stuff in the denominator, and that gives us two vectors that are that you can use to sort of build your equation of the plane. All right? All right, everyone. I'm loving the chat. All right, so let's go back and do another question. Yeah, 44. So just get my stuff ready. Zach, it's up to you if you ignore the X1, X2. It's just shorthand. So I guess the thing is just to be as clear as you can be. Just to be as clear as you can be, and also consistent. Okay, I think that's really important when you're writing mathematical solutions. It's important to be consistent. All right, let me share my question. Right, the last one for today is 44B, and it's a H. Oh my goodness. What does the H stand for? Does anyone know? When I see a H question. Yeah, it means hard, happy. Yeah, love it, Serena. Jeff, yeah. Or what if there was a HHH question? Hospital. So the X, so you can see there's H questions here. They're the harder ones. And you can see X, the X-rated questions. So watch out for those ones. They're for Math 1141 only, right? So you're expected to have a go with the H questions. So I want to do this one here. Can I do that? No. So it's 44B. That's the question we've been given today. Okay. R, Zhengyu, R means routine. Okay. R is like just ordinary. Rabbit. All right. So no problem. So let's have a look at 44B. Find the intersection of the line given by this parametric vector form, PVF, and this plane. Okay, so let's think about it. How, I guess I can draw, let me see if I can do this in GeoGebra. How can a line and a plane intersect? Okay, Rex, it's an interesting question. I'm just going to type this into the chat. That's the big question. How can a line and a plane intersect? Let me see if I can put this into GeoGebra. Okay, I'll just see if I can put this in. So, no, hang on, I'll just kill that and I'll come back to it. Now, let me put the question back up again. Just need a little bit more time. Okay, let me put that back up for a second. And okay, so have a look at that question and my question too, and see if I'm just typing this in now. I'll show it to you in a minute. Okay, and I'm just going to type in the line here. So just wait. So just keep thinking about the question. Okay. So let me share this with you now. Here we go. All right, back to GeoGebra. Here you can see I've got the plane in play. Okay. So if a line is going to intersect with that, how might it work? Okay. Sort of simultaneous equations. Yeah, I think ZG, you're very close there. One point must lie on the plane if they are not parallel. That sounds pretty good to me. Yeah, Lucas, you're on the right track too. They can intersect at a point as well. So let's see if I can get this. I'm just going to pull it over here so I can see. I'm just going to define a point A from our question. So A would be the point -1, 2, 3. Okay. And I'm going to do a vector. which is going to be 2, -3, 4. So that's going to be a vector that is, so let's call that V. Let's see if that works. Sorry. Oh, come back. Okay. Now let's have a look at the line that contains A and is parallel to V. Okay, there you go. All right, so now I'll make that a bit bigger so you can see it. Okay, so let's get rid of that, and we'll keep that. So can you see that now? I don't want to make you dizzy. Yeah. So Lucas, can you see? I think Lucas, you're on the right track there, buddy. It intersects at a point. Okay. Now the line could be contained in the plane, and in that case, there'd be infinite numbers of intersections, right? But here it's very simple. It looks like there's only one point, right? And GeoGebra, I think, can even intersect it, right? P and F. Oh my goodness. So point B is the point of intersection, I think, unless I've done something wrong there. So let's kill that, and we can have a look how you actually do this on paper. So let me see. All right. So I'll share my document camera, and then we can do that. All right. Okay. So this is 44B. All right. So we've got a line, L1, in three-dimensional space. And this is the parametric vector form, or PVF. And we've got a plane which is given in the Cartesian form by this setup here. Okay. So now we want to find out where these two things intersect. Okay. All right. So first of all, let's unpack this a bit more. What does this actually say? Well, it's Rex. I can see your comment in the question, comment in the chat. It's even easier than I think most people are assuming, because if we think of this just as component equations, what have we got? Well, the first component says x equals -1 plus 2 lambda. Right? The middle one says y equals 2 minus 3 lambda. And the third one says z equals 3 plus 4 lambda. I know my z and my 3, they look alike. Everybody on YouTube says, oh, Chris, it's an instant fail. Your z looks like 3. Well, I'm sorry, that's just the way I write it. And the z has a little tail. Okay, so now what we can do, we can substitute this in here, this in here, this in here, and solve for lambda. Yeah, Ziggy, you're exactly right. Excellent. So let's call that star. So I'll just roll that off. So star becomes 9 times this plus 4 times this. It's a 2 minus that. Okay, so you just solve this for lambda. Okay, so if you solve this, you get lambda just by making lambda the subject, right? Okay, so you're going to get, yeah, you're going to get something like -4 plus 2 lambda equals 0. Okay, all right, well, so what? What have we actually found there? Well, we can take this lambda, put it into here, and that will give you the location of the place where these two things intersect. Okay, so let's call this double star. So we substitute into double star to get the following. So this is just the position vector of the point of intersection. Okay. And so -1 plus 4 . Okay, so -1 plus 4, that'll be 3. 2 minus 6, -4, and 3 plus 8, 11. So what's the intersection point? Intersection at 3, -4, 11. And do a little smiley face just to end it. Yay! Yeah, thank you. Thank you. Hope you're enjoying it. Okay. Lucas, then get T. Do we need T? I don't know if we need T, do we? I'm doing 44 part B. So yeah, if you're doing 44 part A, then yeah, same. So let me show you 44 part A. I'll just stop that for a second. So if we were doing 44A, yeah, here, x is 2 plus t, y is 3 minus t, z is 4t. Put those three things in here, solve for t. Yeah, that's great, Chloe. I've got a daughter called Chloe, so good job with the name. Yeah. Okay. Zach, were you asking about the Cartesian form? Someone was asking about going from the parametric vector form to the Cartesian form. Who was that? Was that someone in the chat, I think? Because that's an important question, and we've got like a minute or two to go. So I'll just show you something quickly with the let me share my Chrome tab. All right, so here's my top tip. Okay, so if you want to go from parametric vector form to Cartesian, right? So here we're talking about planes. Okay, for me, the easiest way to do it is go parametric vector form point normal form. And then go to Cartesian. Okay, PNF stands for point normal form. So I'm not exactly sure where you are in the lectures, but I'm not sure if you've seen this yet. I've actually lectured this course many times, but I'm not sure if you've seen point normal form yet. So there is a quick way to go from parametric vector form to point normal form and then to Cartesian. Okay, so if you're worried about it, don't worry, because there is this point normal form, right? So basically, point normal form, you've got a vector in the plane and you've got a vector that's normal to the plane, and this is the equation. Let's say OA. Okay, but if you haven't seen it yet, don't lose any sleep over it. All right. Oh, okay, folks. I've had a great time today, and just want to do a bit of switching here. Let me just switch back to my big head. So I've had a good time. I hope you've had a good time too, and I'm enjoying getting to know everyone, and keep the chat coming. PVF and Cartesian, they're going from Cartesian to PVF, very easy. Going back from PVF to Cartesian is a little harder, but I would use the PNF. But just worry about that when it comes. So I'm going to say goodbye, and yeah, it's been fun, and I'll see you next week. I do have some more tutorials later this week, so have a look, and if you want to come along, just come along and say hi. All right, thanks everyone. Namaste, enjoy the day. I'm out of here.